It looks like we're live. Good morning. Good morning. I need to come and get my chat set up. Also, save this out. Yep, we're still on chapter 9, so we'll tweet this out. And share on topic Twitch. Perfect. Okay, we got that done, and we just need our dashboard. Make sure audio is working. Oop, that's the wrong button. There you go, pop out. Okay, pause there, move that to the left. That's a huge chat window. Let's pop up on my streaming. Okay, there we go. Perfect. Totally shows that I didn't just arrive slightly late and have to set this up during the middle of the stream. Okay, so where were we? Let's go take a look at our previous yesterday, what we finished yesterday. Okay, so currently at chapter 9.3, to panic or not to panic. Let's go load that up. Okay, so CD Savage Project, mine, Learning Rust, chapter 9. All right, well, I think we'll stay here until we decide to make something of this. I'll go to the book. This is the last section of chapter 9, so we'll see how far we get through this time. All right, and with that, let's begin. To panic or not to panic? So how do you decide when you should call panic and when you should call result? When code panics, there's no way to recover. You should call panic for any error situation, whether there's a possible way to recover or not. You could call. But then you're making the decision on behalf of the code, calling your code, that a situation is unrecoverable. When you choose to return a result value, you're giving the calling code options rather than making the decision for it. The calling code could choose to attempt to recover in a way that's appropriate for its situation, or it could decide that an error value in this case is unrecoverable. So it can call panic and turn your recoverable error into an unrecoverable one. Therefore, returning result is a good default choice when you're defining a function that might fail. Good morning. Yes, Miguel. Good morning, Miguel. In rare situations, it's more appropriate to write code that panics instead of returning a result. In rare situations. Let's explore why it's appropriate to panic in examples, prototype code, and tests. Then we'll discuss situations in which the compiler can't tell that failure is impossible, but you as a human can. This chapter will conclude with some general guidelines on how to decide whether to panic in library code. Known Asilia, welcome to the stream. Good morning. Examples, prototype, code, and tests. When you're writing an example to illustrate some concept, having robust error handling code in the example as well can make the example less clear. In examples, it's understood that a call to a method like unwrap that could panic is meant as a placeholder for the way you'd want your application to handle errors, which can differ based on what the rest of your code is doing. Similarly, the unwrap and expect methods are very handy when prototyping before you're ready to decide how to handle errors. They leave clear markers in your code for when you're ready to make your program more robust. Okay, so basically just expect that somebody's going to be using unwrap and expect. If a method call fails in a test, you'd want the whole test to fail, even if that method isn't the functionality under test, because panic is how a test is marked as a failure. Calling unwrap or expect is exactly what should happen. Cases in which you have more information than the compiler. It would also be appropriate to call unwrap when you have some other logic that ensures the result will have an okay value, but the logic isn't something that the compiler understands. You'll still have a result value that you need to handle. Whatever operation you're calling still has the possibility of failing in general, even though it's logically impossible in your particular situation. If you can ensure by manually inspecting the code that you'll never have an error variant, it's perfectly acceptable to call unwrap. Here's an example. So let's see, like they're getting standard net IP address, let home type IP address equals the string.parse to unwrap. Yeah, because I mean, it's absolutely not possible to have an error, a null value, like just nothing out of this. We're creating an IP address instance by parsing a hard-coded string. We can see that 127.0.0.1 is a valid IP address, so it's acceptable to use unwrap here. However, having a hard-coded valid string doesn't change the return type of the parse method. We still get a result value, and the compiler will still make us handle the result as if the error variant is a possibility because the compiler isn't smart enough to see that this string is always a valid IP address. If the IP address string came from a user rather than being hard-coded into the program and therefore did have a possibility of failure, we definitely want to handle the result in a more robust way instead. Guidelines for error handling. It's advisable to have your code panic when it's possible that your code could end up in a bad state. In this context, a bad state is when some assumption, guarantee, contract, or invariant has been broken, such as when invalid values, contradictory values, or missing values are passed to your code, plus one or more of the following. The bad state is not something that's expected to happen occasionally. Your code after this point needs to rely on not being in this bad state. There's not a good way to encode this information in the types that you use. I also think that if you're making like a command line program, we're often used to, when using those, it just crashing to the back to the command line and saying like, look, you can't do that. Try again with this instead. Basically, like crash out and let them try again faster, but still give them the information. If someone calls your code and passes in values that don't make sense, the best choice might be to call panic and alert the person using your library to the bug in their code so they can fix it during development. Similarly, panic is often appropriate if you're calling external code that is out of your control and it returns an invalid state that you have no way of fixing. When a bad state is reached, but it's expected to happen no matter how well you write your code, it's still more appropriate to return a result rather than make a panic call. Examples include a parser being given malformed data, or an HTTP request returning a status that indicates you have hit a rate limit. In these cases, you should indicate that a failure is an expected possibility by returning a result to propagate these bad states upward, so the calling code can decide how to handle the problem. To call panic wouldn't be the best way to handle these cases. Yeah, especially like a rate limited one. I could definitely tell. It's like, well, just like we might be in a loop, and it's like, well, just try again later, or wait some time to try again. When your code performs operations on values, your code should verify the values are valid first and panic if the values are not valid. This is mostly for safety reasons. Attempting to operate on invalid data can expose your code to vulnerabilities. This is the main reason the standard library will call panic if you attempt an out-of-bounds memory access. Trying to access memory that doesn't belong to the current data structure is a common security problem. Functions often have contracts. Their behavior is only guaranteed if the inputs meet particular requirements. Panicking when the contract is violated makes sense because a contract violation always indicates a caller-side bug, and is not a kind of error you want the calling code to have to explicitly handle. In fact, there's no reasonable way for calling code to recover. The calling programmers need to fix the code. Contracts for a function, especially when a violation will cause a panic, should be explained in the API documentation for the function. Does the Rust automatic API documentation mention when a panic will be called? That would be sort of like interesting to note. However, having lots of error checks in all of your functions would be verbose and annoying. Fortunately, you can use Rust type system, and thus the type checking the compiler does, to do many of the checks for you. If your functions has a particular type as a parameter, you can proceed with your code's logic knowing that the compiler has already ensured you have a valid value. For example, if you have a type rather than an option, your program expects to have something rather than nothing. Your code then doesn't have to handle two cases for the sum and none variance. It will only have one case for definitely having a value. Code trying to pass nothing to your function won't even compile, so your function doesn't have to check for that case at runtime. Another example is using an unsigned integer such as u32, which ensures the parameter is negative or negative. Yeah, that was one thing sort of we ran into one of the previous code challenges, which is, okay, what do I want? Do I want to use like the option enum? And it was brought up to me, well, why don't you just use an enum that just has the value you want? And therefore, there are no other potential arms when doing a match to it. It's just that thing, or it doesn't exist at all, which then can't happen because you're creating it right there. You wouldn't be able to create it. So I thought basically that's how we handle this type of stuff. Let's take the idea of using Rust type system to ensure we have a valid value one step further and look at creating a custom type for validation. Recall the guessing game in chapter 2, in which our code asks the user to guess a number between 1 and 100. We never validated that the user's guess was between those numbers before checking it against our secret number. We only validated that the guess was positive. In this case, the consequences were not very dire. Our output of too high or too low would still be correct, but it would be a useful enhancement to guide the user towards valid guesses and have different behavior when a user guesses a number that's out of range versus when a user types, for example, letters instead. One way to do this would be to parse the guesses in I32 instead of only a U32 to allow potentially negative numbers, and add a check for the number being in range, like so. Okay, so we have our infinite loop here. So we create our guess, which is an I32, and we set it equal to, we're matching the guess, trim it from white space and like new lines, parse that into a number, which it sees will be an I32. It's either going to, well, so it's the option, so, or it's a result. So it's either going to be okay, we get the num and return that, or we get the error. And in that error, we just say, okay, continue to the next loop, where it's going to then ask them, well, give me the thing. If the guess is less than 1 or the guess is greater than 100, so here we have the guess now, we then say, well, hey, the secret number will be between 1 and 100, and we continue. Otherwise, we then move on to the actual game logic, where we say, like, hey, let's figure out how are we doing there. The if expression checks whether a value is out of range. tells the user about the problem, and calls continue to start the next iteration of the loop and asks for another guess. After the if expression, we can proceed with the comparisons between guess and the secret number, knowing that guess is between 1 and 100. However, this is not an ideal situation. If it was absolutely critical that the program only operated on values between 1 and 100, and it had many functions with this requirement, having a check like this in every function would be tedious and might impact performance. Instead, we can make a new type and put the validations in a function to create an instance of the type rather than repeating the validations everywhere. That way, it's safe for functions to use the new type in their signatures and confidently use the values they receive. Listing 99 shows one way to define a guess type that will only create an instance of guess if the new function receives a value between 1 and 100. Okay, so we're creating a structure guessed that has that's a value, and it will be U32. Then we put an implementation on guess, which is a public function new. So this is the function that's going to be creating this. Stacking. The fact that Rustbook uses a U32 number when the number can never be more than U8 really bothers me for some reason. I do wonder if maybe they're doing that because they're trying not to increase cognitive load on readers who may not be used to the different number types. I mean, that's one of the things that I'm thinking about, is that maybe they just know that most people are used to 32s, U32. The other thing is that U32, I believe, is it U32 or I32? Is the default. So it might be something like that too. But yeah, I could totally understand that. Like, hey, why are you using too much? Why are you like telling it to use too much memory for this? Okay, so here's a new value. It's going to return this guess. If the value, okay, so then we just check that. Then we panic at this time inside of this. Oh, I didn't know you could do this this type. I was thinking we had to put a format in here, but that actually is nice. But if we make it past this if, then we can return the guess, which then now we can say, okay, we've got it. Then we have public function value, self.value. So are we using value as a function somewhere? Because I'm not seeing. Oh, this is just for external to like get it out. This is a getter. I got it. First we define a struct named guess that is a field named value that holds a U32. This is where the number will be stored. Then we implemented an associated function named new on guess that creates instances of guess values. The new function is defined to have one parameter named value of type U32 and to return a guess. The code in the body of the new function tests value to make sure it's between 1 and 100. If value doesn't pass this test, we make a panic call, which will alert the programmer who is writing the calling code they have a bug they need to fix, because creating a guess with a value outside this range would violate the contract that guess new is relying on. The conditions in which guess new might panic should be discussed in its public-facing API documentation. We'll cover documentation conventions indicating the possibility of a panic. In the API documentation that you create in Chapter 14, if value does pass the test, we create a new guess with its value field set to the value parameter and return the guess. Next, we implement a method named value that borrows self, doesn't have any other parameters, and returns a U32. This kind of method is sometimes called a getter because its purpose is to get some data from the field and return it. This public method is necessary because the value field of the guess struct is private. It's important that the value field be private, so code using the guess struct is not allowed to set value directly. Code outside the module must use the guess new function to create an instance of guess, thereby assuring there's no way for a guess to have a value that hasn't been checked by the conditions in the guess function. I guess the things you have to do to get around the borrow checker sometimes. Yeah, I think that I think is true, but also, so my first instinct is also say, like, isn't this not going to be mutatable? So, like, couldn't this value not be set anyways? I mean, that's just my thought is like, I kind of want to try that to make sure that my assumption is not incorrect. So let's try, okay, go on the left side. Cargo, new, what should we call this? Guessing? We could put it in a panic section. Panic or not. So we'll go into panic or not. We'll open up code here. Also, my screen is very dim. All right, better. Okay, so in here, what we want to do is we want to create our struct. So we have our struct, and we call it the guess. All right, it's supposed to be guess like this, and we're gonna have value, and this is going. We could do U8 here to be a little bit nicer about it. You need to be that. Of course, we're never. Oh, we don't need semicolons on structs. Then we're gonna implement guess, and we're going to create a public function new that's going to take a so what did they take in here? So they took in just a value, and it was U32. And because it's a number, they don't need to worry about like anything on a heap. It's all on a stack, and it's going to return a guess. So this is going to be our number, but its type is going to be a U8, and we're going to return a new guess. And so we're going to say, okay, so if number is less than 1, or number is greater than 100, then we want to panic and say the number, or you entered but you can only use numbers between 1 and 100, and I'll put a number here. Let's close you. Okay, that's our number panic, and of course, if we make it pass here, then we can just return guess, and we'll do value number. And of course, now it's saying like, hey, we can't do that. So let's now implement this. We're gonna say let guess equals guess new, and we're gonna pass it in like 55. So now what they were saying was, well, I guess what we could do is we can access the value with guess.value, right? So like if I want to print line and I could say guess dot value. This gets me that. So let's make sure that we did this correctly here. Cargo run. Yeah, there's our 55. Now, if I attempt to change this, it shouldn't work, right? So if I say guess dot value equals 72, I should get an error here where it says, hey, you can't do this. Cannot mutably borrow field of immutable binding. Now, if I mute this, will it let me do that? Okay. I do see that then. So if we mute it, it won't let us do that. But how do we make this private? Like make it so that this is actually private? The public struct guess value is 32. So I'm not actually seeing how they're really preventing the value from being changed there. Maybe can we put this as like a private? But see the effects of public, you need to call the function from an external place, right? Or you can nest it somehow. Or am I on the wrong track here? You might be. They set the struct and function of pubs. This example doesn't make sense. Yeah, it's like I don't really. Or are they assuming that this isn't a library? That might be what they're assuming. Okay, so I need to remember how to create a library really quickly. Because in source, let's go remind ourselves. Actually, it's in the Rust book create library. Well, so I know it's cargo new lib. I just wanted to convert this one to a library without having to like delete it and do the cargo new lib. So here we are in air handling, common collections, modules. I believe this is where we want it to be. Yeah, the public keyword. So if we move forward. So it's source lib.rs. So that's what we want to create here. So in source, we'll create lib.rs. And it's going to create an example test, but we shouldn't need to do anything for this. We can just put in, we just put our module here. So if we do like mod structure, do you have to do it with a, nope. Like that, and then we can have our functions. Can we have our, do we need to put our data structures in the module? So far it's just talking about how to use functions in it. Extern create communicator, so that's how we're gonna do it. So they don't talk at all, it looks like, about how to use structures in libraries. Okay, that's nice. So let's take this stuff and we're gonna put our structure inside of the library. And I think we do that in this module, like that. Implement guess here. Oh, my tabbing is all off now. Everything's weird. Okay, whatever. Okay, so we have mod structure, we have the struct guess. Do I need to put that? Do I need to set the struct guess to private? If I just set this exactly as it is, we have our new public. Oh, I think we also need to make this mod public. We implement guess with a public function new. We return this thing. So right now, if I save you, and we want to use extern crate, name is, what do we call it? Structure. Okay. Oh, like that. Expected one of semicolon or as found structure. Okay, so what did I screw up here? Where's the section where it's telling us where we're actually using it? And I actually have that code. I should just go take a look at it. Because I did write it. All right, so let's just go do that. That's easier. So that was chapter 7, I think we said. Chapter 7. Here's our communicator. Go to source. We have a main.rs. We're saying extern create communicator. So we don't want to use, so it's not use extern create structure. Cannot find create for structure. And if we take a look at the name of this entire thing is communicator. Let's see. If we cat the lib.rs, it is pubmod network pubmod client. Oh, so we have to, it's the name of this entire thing, isn't it? So it's pubmod, what did we call this? Panic or not, like that. Yeah, okay, so I think it found that. Wait, no, that's not the right one. This one is panic or not. Cannot find crate. But it's right here. I mean, sort of. Because if we take a look at what we had, it was in the main extern crate communicator. The folder that we're in, like the crate that we created, we did cargo new -- lib communicator. Then set up the lib rs and then we added the main rs. Use communicator client, which was the module that was created in lib rs. So extern create communicator. Try to give it : structure. So extern create like this one right here. But it can't find it, so I don't think that will work. It's like expected semicolon. So it wants, so extern create, and then it's like panic or not is the name of this, of the entire module, I believe. Unless like, yeah, name is panic or not. Unless I didn't read these correctly, it's extern create the name of the entire sort of crate that we created. Now, of course, I could be wrong. Like maybe I should just, let's just try this. We'll copy this off, and we can get out of here. We'll go into chapter 9 again, and we'll cargo new dash dash lib, and we'll call this plane with panic. Okay, so let's go into plane with panic and open up code here, and just see what difference we have. Maybe there's something slightly different, like the cargo. No, that looks the same. librs. Like, we don't need any of this code. And if we have, okay, pubmod structure. Struct is never used. Method is never used. Okay, so that's fine. We come into here, we'll do new file, main.rs, and we'll say extern create plane with panic. So it seems to find that. If I save it, no errors. Okay. I must have done something wrong with sort of like playing with that, because now we're doing that, and we can say use plane with panic structure. That. So now we have, yeah, now we have the structure, and so we could just function main. And so in this one, we're just going to say, okay, let's create our new guess. So let guess equals structure. Where is it? Structure guess. This has to be public, doesn't it? And this has to be okay, structure guess new. And we give it the number, which is like 55. Then if we just try the same thing, we'll print line, I'll give it guess dot value. So we should be back to have everything is working again. And we'll do cargo run. Okay, errors here. Field is never used value. Wait, really? Field value of struct is private. So in this case, it is private. So in this case, we do need to now put a getter in here to have, okay, we have a public function value. It doesn't take anything. Oh, I guess it takes a reference to self, and it returns a U8. And in this case, it's going to just return value. Return self dot value. So if we come back to main, guess.value like that, I think. Okay, so that works, which means that even if we create this as a mutable thing here, we can't say like guess.value equals like 72. Like this shouldn't work. It should yell at us and say, hey, that's private, you can't do it. Yeah, method name value also exists, perhaps you wish to call it. Yeah, so it's telling me you can't do that at all. Yep, it's private. So I think it would be a little bit better if this told us that this was in the library and that's why it exists like this. That's actually really interesting. Okay, so that was just all to verify that. Let's do we look through here. Next, we implement a method name value that borrows from self. Oh no, we have that one. A function that has a parameter or returns only numbers between 1 and 100 could then declare in its signature that it takes or returns a guess rather than a U32 and wouldn't need to do any additional checks in its body. Summary. Rust error handling features are designed to help you write more robust code. The panic macro signals that your program is in a state that it can't handle and lets you tell the process to stop instead of trying to proceed with invalid or incorrect values. The result enum uses Rust type system to indicate that operations might fail in a way that your code could recover from. You can use result to tell code that calls your code that it needs to handle potential success or failure as well. Using panic and result in the appropriate situations will make your code more reliable in the face of inevitable problems. Now that you've seen useful ways that the standard library uses generics with the option and result enums, we'll talk about how generics work and how you can use them in your code. Ooh, so we're finally getting to generics. But yeah, so that is a super interesting thing that we sort of ran into, which is they were talking about library code this entire time, not necessarily our code in main, where we could sort of panic to our heart's content. But it also sounds like, oh, well, if we just create our own libraries here, then yeah, that might be a good thing to do. I was also a little bit weirded out that we couldn't get this file to work. So I'm kind of wonder what is the difference here? We have lib.rs and main.rs. We have lib.rs, main.rs. Okay. In playing with panic, as an alternative, had to look it up as I completely forgot, but you could also use a test. Tests can treat libraries like an external crate. So you can just use the lib.rs file and put a test underneath the current code. Oh, really? Okay, hold on. So they never had us when we went through that, they had us delete the test and not use it. So let's actually do that and write the test in here, and then we can run the cargo test, I believe. So I think if we come back to chapter 7, here it is. This is the code we initially had in here. So configure test, so mod tests. So even if it's pub, it's only pub in the lib.rs scope and can never be pub to the caller in any case. Well, what's interesting is that we had to make the struct public. But this function is public also, which is available, to make it available to the call to the main function. And this could be used to the main function, but this value is. Now, if I set this, can I set this as public value and then not have this value in here? Because that's another good question. Also, we want to check out, so check out what we have here. So mod test function, it works. Well, let's just run this right now and then see if we can get the test, like that canary test to work. And then stacking, let's sort of take a look and play around with the public and see how it works. I think it's just cargo test, right? Oh, it ran the main RS file. Okay, hold on. How do we actually run? Did it even say how to run the test in here? I don't think it did. Let's look it up. So cargo rust run test. Cargo compiles your code in test mode and runs the resulting test library. You can specify command line options. Okay. To separate these two types of arguments, you can list the arguments that go to cargo test following the separator. Oh, this is chapter 11. So we're going to talk about testing later. But what's really interesting is that I'm going to have to come in here to main RS and not use you at all. Save that. And then do cargo test here. And of course it's saying, hey, you're not using, but okay. So one test pass, which is it works. So if I also comment you out, so we have an empty main. We have it works. So we want to also set up a test. Say, okay, function. You can call this guess. Testing guess. Can I just guess works? I'm not sure what the best name is because I would want to say like, oh, just guess. But I was thinking about like the it system and like a Mocha Chai setup or some kind of like unit testing system, but that would be a string. So okay, so guess works. We could figure out good naming later. So I want to, do I have access to these structures right here? So for example, can I just say, let my guess equals guess new, we'll do 42. And I want to assert equal that my guess dot value is equal to 42. Let's see if this works. Use of undeclared type or module guess. Okay, so I have to pull this in here. So like I have to do use, I mean, do I have to fully bring it in? Like, or can I just say user or I'd have to do like extern crate plain with panic, and then use plain with panic structure guess. Okay, will this work? Okay, so cargo test. Can't find the crate. Hex turn crate. Playing with panic. Okay. We're in playing with panic. That literally worked right here. So I guess I'm not really sure how the tests work yet, and we see that it's coming up in a chapter or two, or so that's probably where we'll be playing. Like we'll just like play with it a little bit more there, I guess. So I'm just not going to worry about these tests right now. Then, now as for this, we wanted to try putting the public value 8 here. Where, okay, so we're bringing in panic, we're bringing in the structure. We have structure guess new, and then guess dot. We can then, are we allowed to set the value if we set that specific structure? Not test. What is it? Cargo run. No method name value. Found for type. Do we try to use the value? We did. We really want to just use it again because we didn't. So 72. So yeah, it's now set. So if in the library we want to be able to sort of like let the user directly manipulate the value, we can make this public. Otherwise, it's private, even though the structure is public. Each item that's stored in the structure can be public or private. So stacking, I hope this answers the question. So even if it's pub, it's only pub in the library scope and can never be pub to the caller in any case. I think it's more of like the entire structure is public and each pair value. So we can have like value and we can have like other, which can be something like a, it could also be a U8. So this sets like the number. We could set guess is value number, and we can also do other number. Yeah, no, that's sort of what I was figuring at the same time. But what I believe what this really means is that now we can say that you, other, are public and you are private, and so therefore the only way to get it is through something like this. So now we could say, okay, guess.value, this has to be like guess dot other is going to be 72. We're going to pass in 55. We can do like comma like this. So guess.value and guess.other. And this should just work. Yeah. So it's super interesting where we can make those design choices in here and choose whether or not we want to do that. All right, we're coming up on 8 o'clock, which normally is the end time. However, I have taken the day off of work today, so I don't need to like super fast rush out of here right now. But I also don't want to sort of continue playing with going through the rest book. So I'm gonna wrap up that, and then I'm thinking I'm gonna do a few code battles on codinGame because I've been wanting to sort of like explore a little bit more of that. I think those are sort of a fun way to continue practicing Rust. So let's save, close all of these. Save you. Let's see what we got. So if you come down, we are playing with panic and the propagating errors and a panic or not. where were we? We were just in playing with panic and everything was fine. So we want to keep that one. The panic or not is the one we want to remove. So remove rf panic or not. Let's also cd down and vim the readme. So we're no longer going to be on chapter 9.3. From now on, we're going to be in the next section. So we were right here, chapter 9.3. Now we're going to be on chapter 10. Generic types, traits, and lifetimes. Perfect. We'll throw you in there. There we go. And let's see what we got. Okay, so git add everything. That's what we want to see. So we're going to do git commit finished chapter 9. And we'll push that on up there. Okay, so with that being said, let's go and load up codinGame. So if you haven't seen, codinGame is a fun little sort of game that has lots of different coding options that we can do. Can I close? No. Yeah. And there's all these practice things that we could do. I was trying to work through a puzzle and it's been a long time, so I've kind of forgotten what was going on in there. It might be easier to do now, but yeah, it was ASCII art. We're partway through this, which is supposedly an easy puzzle, but I've been having a little bit of trouble with that one. Let's see if we. Right, ASCII art allows you to represent forms by using characters. To be precise, in our case, these forms are words. For example, the word Manhattan could be displayed as follows in ASCII art. And so they hand us, if we take a look at the input, they hand us like all this ABC. So it's like 4 is how wide each letter is, 5 is how low it would be, and then which letter we want, which would be like the E. So that would be here. So we'd want to loop through and say, okay, well, on the first pass, we're gonna print line and say, okay, I want this to be printed. And then we go through again and we say, okay, now I want this to be printed, and then the third one and the fourth one and the fifth one. And what I ended up doing, I think I'm going way overboard with my logic and over engineering it to like basically say, oh, I want all of these things individually stored in a hash map. When it's probably more of like I have this string. Is it like I don't even remember what kind of string I have. It seems pretty. I think I would want to restart with something like this. So I'm not going to do that right now. I probably will do that either offline or in another stream when I'm feeling more like starting it over. But in the compete section, which I played a little bit around with last night just to sort of see what it is. There's these like full code like making an AI that sort of like walk you through it, but still it's pretty involved. But there's also these clashes of code, and so these are kind of fun because they're just like, okay, they're short things that happen, and And when they do, like they're 15 minutes at most, you could usually finish them very quickly. This one is literally the first person to finish wins. So we're probably not going to win in this one. And we got a lot of people playing. And reverse mode. You have to guess what to do by observing the provided set of tests. So that's actually the game mode is reversed. You don't have access to the statement. You have to guess what to do by observing the following set of tests. So you can play the first test score based upon this. We gave it answer, failure, found ants, expected 19. We also have this inputs readline.split. So start range is parse in input 0, end range is inputs 1. We could put what is, we want inputs. Inputs doesn't look like it has a debug on it, so we might not be able to do that, but we could do start range. Oh look, the Ruby guy is already finished. Start range. And it's like that. And we'll put in start range and range. If we throw this in here, we could see what the range is. So start range. Oh, you're just print. I want print line. Oh, I'm in JavaScript. That's why. I want to be in Rust. Yes, I understand. All my stuff will be changed. Okay, so here, inputs. Yeah, it's put into a vector for us. There's no debug on the vector, so we won't be able to print that out easily. Although we might be able to. So we could just say inputs. How about that? Or is it like, oh, I just suddenly forgot how to do the debug. And then we'll try inputs. Let's run this, see what happens. Okay, so for inputs, it is 4, 2, 5, 8, and then a new line, because they gave us that. That's interesting. It expected 19, so 4 plus 2 is 6, plus 5 is 11. Oh, it sounds like it just wants us to sum that up. So let's try that. We have start range, end range. We probably don't really need, well, end range. Okay, we could loop through these. So we could probably say, okay, do we want to map or reduce? There's a bunch of different ways to do that. We could just do a let mute result equals 0, and then we want to for number in, it's gonna be inputs dot, how's the thing, so it's input line dot split. I think we also want to trim this if possible. I want to make sure that this actually runs it without that /n. Oh, it didn't. Well, that's actually, I wonder if it's just because this print line put that in there, but that's not what I wanted. Anyways, so let's come in here. We have our that mutable result equals 0. We're gonna do for number in inputs dot iter. So now we should have each number in here, and we just want to say result plus equals number, and then we're going to return the result. See if that works. Errors, no method named iter found for type. Standard string string. Oh, inputs is a it's collected into a vector. Just call it again and trim it in your code. I don't think you can change their code at any point. Oh, so that's the problem. Okay, so I can't change theirs. Although I thought I could just add that in there right here. So they're creating a vector, but what was? I want to double check. Like, what is inputs really just a string here? Inputs is 4, 2, 5, and 8. They have let inputs equals input line split. Oh, so it looks like it really isn't what I expect it to be. This is just a string. It's not a vector. That's actually really interesting. I thought it would collect it into one. Or at least that's kind of what I was hoping it would be. So I'm thinking I have to myself to write an action using println message to debug println debug message. So I need to now sort of iterate through these, but I think I need to split it again. So if I do let sort of numbers equals inputs dot split on the space, can I trim it here? Dot collect. This will probably tell me. Oh, I need to parse it too. So dot trim. Oh, it's because, yeah, inputs equals input line dot split. This is parse input right here for each one of these start range ones. And parse input here does the trim parse unwrap. Okay, I'm starting to get it now. So we can, I don't need to do anything crazy here. I can just do a for loop. A for loop through this and do that. We get the end range and the start range. End range equals parse input inputs of 1 I32. That actually seems really weird because we got 4, 2, 5, 8. Like 0, 1, 2 is not that. We wanted to add them all together. So what I want to do is take this and just loop through inputs. Input should be a vector, so I should be able to loop. I should be able to loop straight through it. So for like whatever it is, single in inputs dot iter, we can maybe just sort of let num equals, and we can now use this same thing like the parse input. Parse input, it's the macro that they create up here, and we're going to then hand it the single. We want a result. So let mute result equals 0. And parse input, we also want to set this to be an I32. And then we're going to say result plus equals num. And then we'll see if we can pass in the num. Cannot find value num in this scope. Oh, the result. We want the result. No method name iter found for type standard string. So yeah, I thought it collected it into a vector for inputs. Oh wait, you know what? Its inputs got disappeared here. I wonder if I can do this outside of here. Input line. Input string is new. I think I need to put all this stuff inside of the for loop. Where did this come from? Because like m equals parse input, take the input line I32. So 0 to m is usize. For I x2 parse input line. Oh, it's mutable right here, but we're shadowing it with inputs. So this is not in the same start range. That seems really weird that they would put this in here. Okay, so we have to kind of do this all again here, which is we have our inputs, it's a string, so we need to, it's fine to do that there. Let's say that input, Rest really needs to work on a standard in library. Who thinks this is, I know, this is crazy. Let input numbers equals, okay, so let's see if we can like do what we're doing right here, which is we already have the read line mute unwrap that inputs. They're doing it twice, it feels like. That's so weird. But we have inputs available to us, which is this inputs or this Okay. So equals inputs dot split on the space. We'll trim it. Then we'll dot collect it into a vector. Then we'll do this and we'll go through numbers. We'll iterate through that. So let's see what we got. Errors. No method found trim for type standard split in the current scope. Okay, so we can't do trim there. Can we do trim before? The type of this value must be known in its context. So we can say that this is going to be type for vec unknown 19. So found nothing, expected 7. Wait a second. I thought the first thing was it expected 19. Okay. So let's try the inputs again in here. So it's 4, 2, 5, and 8. Expected 19. Wait, if I just pass the string 19. Found nothing, expected 7. So that's definitely not what we want here. Okay, so the game user test 1 4 is 19, 4 2 7 8 is 7, 3 is 8. Zero, 1, 2, 3, 4. Okay, so this is... That was really, really weird. I didn't sort of understand that test at all. But we can try another one. So I think that one was just not understanding what they wanted in the test. Combined with not understanding what they were giving me. I thought they were giving me an array or a vector, and they were giving me a string. And I didn't know if I was supposed to put my code into the for loop or not. So some of these are a little bit interesting, and some of them are really like good. I don't really like those the reverse ones as much. Yeah, I couldn't figure out where they got the 7 and 8 from. Yeah, that was really weird. I probably should have left like a review on that and said like, well, I didn't get that one at all. All right. So this one, maybe it will start right away as soon as this one gets here. But what's really cool is that if everybody has a account here, it can be done with like friends. So I could like give out a link to it. You have to pass the maximum steps as fast as possible. Oh, great. Okay, so given two numbers, A and B, you have to count how many numbers within a range belong to the following categories: multiples of A, but not B; multiples of B, but not A; multiples of both A and B, none of the above. For example, given A equals 2 and B equals 3, within 1 to 20 inclusive, we have category 1, 2, 4, within 1 to 20. Oh, so how many times is a multiple of 2? How many times is a multiple of 3 of 1 to 20? And that's it. So we have A and B, and then S and E. So that's the start and end. So we're gonna have to count. We'll have to do like a let mute count A equals 0. Let mute count B equals 0. And so this is multiples of A but not B, multiples of B but not A. The number count in each of these categories are, and that's what we return. A not B, B not A, A and B neither. Oh my gosh. Okay. So, for example, given A equals 2, B equals 3, from within 1 to 20 inclusive, which is these here. So I can do a for I in, that's an S, right? S to E inclusive, so plus 1. What are we gonna do? We're gonna say, okay, how many times that it's multiples of A but not B? Oh my gosh. So it's really gonna be A not B, B not A, let mute A and B equals 0, and then none. So let mute none. Okay. So then we loop through here, and I think it's just still modulus, right? So I can just do like, okay, so if A, which is an I32, and S and E are I32s, so we should be fine with that. So if A modulus I is equal to so if it's multiples of A, that means it's a modulus 0. So this means it is a multiple of A, then, well, okay. A not B. And B modulus I is not equal to 0, then A not B plus equals 1. Oh my gosh, this is B not A. So else if B modulus I is equal to 0 and B modulus A modulus I not equal to 0, then B not A plus equals to 1, A and B, else if A modulus I is equal to 0 and B modulus I is equal to 0, then A and B plus equals 1. And then finally, an else where we're going to put in none plus equals to 1. And at the very end, we're just okay, so it's going to be first one, second one, third one, fourth one, A not B, B not A and B none. All right, let's see if it passes the test. Standard output stream, we got 11117. Found 11117, expected 7337. Okay, so that's not correct. At least we're not the last yet, but everybody else is fine. I'm the only one doing Rust, so that's probably to be expected here. We can look at the first test case. It is, we got 2 and 3, and then 1 to 20. So, and between 2 and 3, 1 to 20. So, A not B, so A modulus 1. Is this the wrong way? Should I be doing I modulus A? Like this? I modulus A. And I modulus B. I modulus B. Modulus A. Modulus B. Modulus A. And none. Let's try this. Aha, that works. Play all tests. And we'll submit. We got leveled up to apprentice with that. Okay, we weren't the absolute last, but we're the only one using Rust against Python and Java and Ruby. I think after this code clash, I'm going to call my parents and ask them where I got my lack of smarts from and have a long talk with them. Oh man, this one. I'm willing to share that, I guess. I don't think anybody else is using Rust. But that one was like, I guess I haven't used modulus in Rust yet. So let's do one more, and then and then, well, I can go up till like close to 9. So let's keep on doing these and see how hard they get. These seem to be like fun practices of Rust. All right, which one is this? Reverse mode again. Have to figure out based upon the tests. So, okay, so test 1, 2, 3 is what? A plus take has. Failure. Found answer expected 2 divided by 3. Okay, so we have let main equals input line, so we get our input line, standard in, read line. We just taken in this, let fraction equals read line. Okay, I want to know what the heck is this? Fraction. Try again. Okay, so this one, the first one passed. Like it says 2 divided by 3. This one found 2 divided by 4, expected 1 divided by 4. Oh no! Oh no! We have a string. Our fraction is a string of 1 space slash space. Oh my gosh. And we're gonna have to see that this is divisible by the second number, and we're gonna have to divide them and then return that. Okay, so hold on. We can do this. We can do this. We're all right. I'm glad this is not a speed one. We're gonna have to now first turn this into a vector for us. So we'll let like the pieces of it. So the parts is and this is gonna be a vec of type who cares, and I'm just happy you understand the question this time. Yeah, I get it, but it was like, oh, if I'm using another language, this would be so much easier. Okay, so let's put this into a vector, and then we can access each part with the indexes. So we're gonna take our fraction, and we're gonna have to split it by spaces. It looks like. It looks like they were nice enough to do that. These are all. You know, can I do split like this? Split by space slash space. We'll dot trim. We trim on this side. And then we're going to collect it. Okay, so that will give us the parts. So if we take a look at what the parts we have is now. We have to debug, print it. It's 2 and 3. Oh, okay, that's perfect. So now we could just check. We're only going to get 2 things here, it looks like. So first of all, we can now check to see if the right is oh, I can never remember the rules for modulus, because I mean, you saw me last time. I always sort of like get this wrong. So if the left one is divisible by this one, we want to divide it by that one. So this one becomes a 1, and this one becomes a 2. So it would be something like if like we could say let left is gonna be the parts of 0. These are all strings too, but they have this parse input with the type. Oh, and I always forgot how to use it. It's gonna be parse input bang. I'm gonna give it part 0, and we'll do it an unsigned 32 because we don't know how big these can get. And so that right equals parse input parts of 1, U32, that. And so let's now, we'll do the, let's just see if we can sort of recreate what we initially had, which is we have left and right, like that. 2 divided by 3, that works. So we're successfully getting that. It now wants, okay, 2 divided by 4. So now that we have that, we want to say, okay, if the left modulus right is equal to 0, then we probably want to mutate this, allow us to mutate this, where we're going to say, okay, left equals left divided by right. So if I do that, that didn't do anything, so maybe it has to be right modulus left. Oh, we still got 2 divided by 4. Oh, it's modulus here. If shouldn't be right modulus left. You're right. Right modulus left. Found 0 divided by 4. Perfect. And now we want to say left is right divided by left. Wait. It found 2 divided by 4 still. Left equals right divided by left. Loads of delay. I know there is. I wonder if there's a way for me to like change that so there's less of a delay for us, because now the internet seems to be pretty solid. I got a beep from this and I have no idea what that means. Was there like some chat? Oh. We haven't run out of time yet and nobody's finished it. Okay, so found 2 divided by 4, left equals right divided by left. That, wait, do I just want to do left equals left divided by left? Is that what I want to do? That becomes a 1. No, definitely not. So that won't work with the next one. You are a partner, so the low latency option. So I'm not a partner, I'm an affiliate. So as an affiliate, I get some of the things a partner, but not all of the things. But I can check to see if low latency is an option in the dashboard. In fact, I could check that. Well, let's actually finish this. I'm on a time schedule. I've got 6 minutes left. And I'm feeling that this was going to be another failed one. Even though we know what to do, I just don't know math well enough to do it. I need to call my wife down here or somebody. Okay, so if right modulus, I want to say like, okay, if the left can go into the right evenly, we divide. And so it goes down. And I'm trying to remember, how did I do this in longhand? I need like a whiteboard here for me to do this. So we have this 2 divided by 4, which is what we get in this one. 2 divided by 4. The 2 goes into 4 one time. And so this reduces down to 1. And this reduces down to 4. It's not like this gets divided by itself, because that turns it into 1. This gets divided by 2, so the right hand side, if the right modulus left equals 0, what if we just say, okay, the right equals the right divided by the left. See if what that does. That makes it the 2. So then we also want to say the left is equal to the left minus 1. I mean, that will work for this one. Will that work for this one? Probably not. We put in 105 and 132. We found expected 35, 44. So it's not divided by 1. It's not minus 1. So if we have like 2 divided by 4, 2 goes into the 4, and that's why. But if we have like, we have 10 and 20, we divide each by 2, right? So 5 and 10. Is that how it goes? So left equals left divided by 2. So it works in the second one. Does not work in this one. 105, 135. Oh, so I don't know math well enough to figure out the fractions. Oh, what is even the algorithm called? It's algorithm to calculate. Oh, isn't it it's like the least. I don't actually know the words right. I don't remember the words. So it's like the calculate the it's the greatest denominators or the greatest stop trying to be helpful and like you're not. Yeah, I don't think I can do this one. Mainly because I'm just terrible at math for this. Oh my gosh, this is so horrible. I think you need to find the smallest common denominator. And then do I divide by it? So if right, is it the smallest common denominator that's equal to both of them, right? Then I divide that by both of them. So it wouldn't necessarily be this. It would be, I want to let mute common, or no, the common would be our for loop. So we could say for common in 2 until the right. Okay, so common in 2 to the right, and then we're going to, then we can test to see if they're divisible by that. So if, I think it's common modulus left and common modulus right. So if those are, then we want to say left equals left divided by common, right equals right divided by common. And then we print left and right. So let's play the test scores. Nope. Mismatch types. If common and left, modulus left, common modulus left equals 0, and common modulus right equals 0. Play all test scores. Nope. Found 2 divided by 4. Expected 1 divided by 2. Did I do this wrong again? Common, is this supposed to be left? Common and Right. Time's out. Hey, my... Oh. Well, I also messed up the code, so it's gonna get 0 because I was sort of rewriting it. I had like 2 of them passing. I'm not feeling bad. Everybody else did not get 100%. All right, so let's come and take a look and see what I can do. Where is that? In channel. Oh, low latency, right there. There's nothing else for me to do. So live. No. That. Okay, so I don't know if that takes effect right away or if like it'll be just the next time I stream. So let's hey, I was not last place in it. Let's do one more and try it out. Let's test out the low latency thing. Next stream. Okay, so next stream we'll have low latency, and as soon as I make a mistake, you guys can all tell me how big of a mistake I've made. Nobody is telling me I need to do anything right now, so let's do this. I feel like this is more practice for like a job interview. Like, as someone who had a lot of math under his belt, I feel ashamed. My fun thing is like I'm dyslexic, so part of the dyslexia is like mixing things back and forth, and it does another fastest possible. Okay, Brain is a programming language designed to be extremely lightweight. Your task is to create an interpreter for mini brainfuck, which features just 3 commands. Plus adds 1 to the value. Minus takes 1 from the value. And what is that? Dot outputs the character representation of the ASCII value. Note that any characters that are not commands are ignored, allowing easy notation. Input C, the code, a long line of commands. Output, the output that your interpreter gives. Constraints, length of C is less than 1024. Okay, so they won't screw me over with that. Example, input is a bunch of these. Output is hello. Okay. Wait a second. So C equals input line, trim line, 2 strings. So C is literally just a string of this. So if I was to just check to see what C is and play the test case, that's what we got. So adds 1 to the value. What do we start with? Takes 1 from the value. He's done already. Oh. Dot adds outputs the character representation of the ASCII value. Note that any characters that are not commands, but is this like outputs the character representing of the ASCII value? So am I starting with like 0? Am I saying like, okay, let mute current equals 0, and then we want to iterate through the string? Okay, so if I do for like Mike C in C, I can't do C. My CH in C dot cares. And if I say if CH is equal to the plus, well, at this point in time, I kind of want to just print line what ch is, just to see it. To debug, use ePrintline. Okay, so I want to use ePrintline debug message and just see what these characters are. Try again. Okay, so it's literally the plus. So I can now say if character is equal to the character plus, then I want to say current plus equals 1. Okay, so minus, so else if character is equal to this minus, then current minus equals 1. And then outputs the character representation of the ASCII value. So we also need so it's our output is going to be equals to string new on the heap. Okay, so if we do this, then finally else if, I guess it can only be an else. So if it's this dot, we want to then take whatever this is. So it's going to be current, like the ASCII value of current. Okay, so Rust ASCII value of character. There must be something on char. The e.chars is digit, 2-digit, escape Unicode. No, that's not it. Length. Okay, so is there anything I can see is here? Is ASCII to ASCII lowercase. Makes a copy of the value in its ASCII lowercase equivalent. ASCII letters A to Z are mapped to A to Z, but oh wait, no, I want to take like from Unicode or something like that. This is a nightly only experimental. I probably can't do that. Into? No. The problem with this that I'm running into is I don't know how to convert from the ASCII. Is ASCII uppercase? Is ASCII alphabet? Okay, let's try Rust IDE. I want the what is that front end like? Try Rust in the browser. Oh yeah, I think there's like a bunch of these too. Okay, so that main I don't care about any of that. I want to say if I have we have a character that is we let my number equals like 33. Can I say print line and it's gonna be essentially the character version of this? So there must be some like standard conversion because I have no idea how to convert this over to a char. I don't think I can do like char 33. Not a function. Did I do the convert rest convert ASCII convert to ASCII? Convert an ASCII string literal to UAS. Convert U8 to char. That's what we want. 65 U8 as char. Wait, really? That's all? So wait, I could just say current. So we're gonna say output dot push. It's gonna be current as char, like that. Oh my gosh. Then we're gonna print current, and then this is gonna reset current equals 0 and do that. Again, only U8 can be cast as char, not I32. Current, this has to be a U8. Cannot borrow immutable local variable output as mutable. Output needs to be equal as well. I got 0. Found 0 is hello. Oh, I want this to be output. Found H/29/7. Well, I got the H. Like there's that. Current equals 0. So output dot push. So we're adding that in as current as char. I think this needs to be like a U8 also to set that up. Try again. So current U8 equals 0. Current plus equals 1. Current minus equals 1. I guess I could do like an else if char equals a dot. Then we want to do this. I don't know if they're going to do anything silly for us. Nope. So we had a slash here. What is this first test case? They're just handing us a bunch of pluses and dots. That should be hello, okay? Length of that. Oh, right, we got it here. So any characters or commands are ignored, allowing easy notation. So if character is plus, current plus equals 1. If current, else if current minus equals 1. Else if the character is a dot. We push to the output what the current is as a character. And then we reset current to 0 to then continue on with the new one. Like that, I think that should be working, but why are we getting this slash? I kind of want to push in, what is it? E print line Do you have to take the length of the string or something, then do math towards that? I mean, I shouldn't, because unless there's something weird in the characters in a c.chars, but it's pluses, right? It should be. I mean, I guess what I could do is, instead of just like going through the chars like this, I could also do these are just c dot iter, and go through that way. Then these will be strings, I believe. So we have like minus plus dot no method name iter found for that, so we also need to let our vector for this, which is going to be our basically our string and vector format. So inputs, which is type vec, is equal to c dot, let's trim it, dot split on every single character. I think the problem here is you need each character as its own byte instead of taking the whole string. Well, I think I was getting it because I got the first H, so it did the first one, but then like dot isn't working, I think. Dot collect, and then maybe we can do inputs. No! It won't let me redo it. Okay. That was, I think we did 1 or 2 successfully, and the rest of them have just been, yeah, Rust was not for that. Also, it didn't actually submit my stuff. But Python 3 has been killing it. Ours is not as much. But let's go back to home. It is 9 o'clock. I am going to have to go and do other stuff, but this has been fun. Look at the C code. That would have been coast. Oh, wait, can I go back? View code. All right, so what do they got here? They included auditor coded below elements that helping you parse the standard input. They're creating an array of 1024 or 1025. They get C, they get this from standard in, int r equals 0, or int I equals 0, int standard like C. So iterate, so do a standard iteration through this array of characters. If the character is equal to a plus, r plus plus, the character is equal to a minus, r minus minus, else if c of I is equal to dot printf a character and then the r, and then move on to the next one. I mean, that will... I think... Well, the fact that they could print from a number to a character like that does help out. Is the number that I was getting like not resetting properly? Like I was thinking that could be potentially the answer. So I wasn't like adding into the string properly, because I was getting those slashes. So I wasn't really sure what those were about. Or was that the as care pushing that in? String. Well, oh wait, you shouldn't reset the counter to 0. That is why there is a dash or a dot. That might have been the problem. But it's too late now. I'm curious, like, if I keep on doing these, will I run into the same one over again? And is that the reason why some people are like really fast, or are they just really good at this and they just do it all day and they're used to it? I have no idea. But we can take a look. We ranked last place. 4 out of 6, 6 out of 6. I mean, so for most of them, we didn't get last place. What's really cool is that we can come over and like look at some of these again. And I think in our public profile, I don't think I can see all the previous ones I've done. But it might be more code clashes do repeat. They only have a set amount of them. So eventually I'll get to those and I'll just, like, they'll be easier next time that I run into it, maybe eventually. I think doing some of the other competes eventually might be interesting. But until then, I do have some people coming over soon, so I'm gonna have to go get ready for that. But it's been super fun doing an extended morning stream. Hopefully I'll be able to do more of these in the future, or maybe just do unannounced streams where just just doing some fun stuff. Anyways, I'm generally doing these early morning learning rest streams at 7 a.m. Mountain Time every single weekday. So I'll be back on Monday morning to continue chapter 10 of Rust. I am taking Monday off as well, so I don't actually know what my morning schedule is, so I don't know if it's going to be an extended day or not. Besides that, you can find my videos being archived over to YouTube. I announce these videos on Twitch usually right as soon as I start streaming, or you could just follow me on Twitch here, or follow me on YouTube to get announcements when push notifications when my videos go live and are archived and everything else. Anyways, if you have any questions, comments, feelings, or just like to help me actually do the things better, please leave comments in the videos or just send me a tweet. You'll go bash your head in until then. Don't bash it in too much. We could try it again later and maybe do better next time. Until then, thank you for watching. Thank you everybody for chatting. It's been super fun, and I'll see you all next time. Have a great rest of your day. I am definitely more awake now. Extended stream, yes. I mean, those are always good. All right, with that, I am definitely out of here. I'll see you guys next time. Bye.